We are using the squeeze theorem. Squeeze theorem usually applies to the x over sine x function as x goes to 0. As x goes to 0, the bottom goes to 0. It always starts at 0. And then the top goes to 0. So this is that indeterminate form, 0 over 0. So the trick that they use is they use some sort of graph that comes in from the left and goes to 1 and then stays above the function. And then we use another sort of graph that comes in, goes to 1, and then always stays below the function. So it says that if we know the outputs of these two graphs, then it squeezes in our x over sine x function into 1. So the answer for this, as x goes to 0, is equal to 1 from the squeeze theorem. All right, so they're just pretty much saying everything always has to be above it for one function, everything always has to be below it for the other function, and they both have to merge and touch at 1. So they're touching there at 1. All right, let's see what the problem looks like. All right, to prove that, Madison suggests that we use the function absolute value. And, well, it's these two, g sub x and h of x. And it's nice that they're giving us a graph here. So as we look at this graph, what's the issue from what I've just said? Okay. So it did not touch 1 on both of them. So they have to squeeze into 1. So what this says is that it would have to lie in between these two. And that's not enough. That's not enough. So it's not in between these two. It has to go to 1. So that's the issue here. This is not acceptable. Seems to be correct. Nope. No, Madison, because it's not true that one function is always below and one function is always above as it nears 0. No, it is always above. It is always below. The problem is incorrect because g and h both do not equal 1 at that when x is 0. Okay. That's our strategy here. If you have trouble, you always look over their answers too, and using that hint can help you. All right, so taking a look at this. This one's looking a little bit better. All right, so notice this one. Is it always above? Well, it cuts off right here. It cuts off right here. So if we just looked at it between -2 and +2, it would be okay. So notice that is incorrect because it is not true that the output of one function is always below f of x. The output of the other function is always above x as it nears, for x values near 0. So that's the key, is that as we get closer near 0, it does have that behavior. So the restriction would be, I would say, from -2 to 2. We're okay with the squeeze theorem here. So yes, it seems to be okay. A little bit tricky on this one. We're not always above or always below, but it should be. It's not too bad to find functions that are always above or below, but if we have to, we can kind of limit the frame here. All right. So I think that should be a good indicator of how to get through these problems with the squeeze theorem. And I recommend making sure you look over the actual proof of the squeeze theorem. Let's see if it's here. Intro, limit as x goes to 0, limit, and then we got the cosine one also. All right. So I would recommend make sure that you look over these videos.